you can remember that this discrete random variable we consider. Let x be a discrete random variable with the probability mass function given by Pxx. This is equal to 1 by 4 whenever x is 1 and 2. This is equal to 1 by 2 whenever x is 3. This is equal to 0 otherwise. So, you can check that this is a probability mass function because it is always greater than equal to 0 if you take sum of all the values, but it is not a uniform distribution because probabilities are different. For 3 it is 1 by 2, for 1 and 2 it is 1 by 4. So, what will be the mean and variance? So, if you find the mean, so expected value mu x is nothing but expected values of x. So, this is by definition summation of xk px of xk. So, then this is nothing but xk, what are the value it can take? 1 into px of 1 plus 2 into px of 2 plus 3 into px of 3. These 3 values it is taking 1, 2 and 3 plus there is no 0 other values. So, that is why only 3 values it is taking. So, this is 1 into what is px of 1, this is 1 by 4 plus 2 into what is px of 2, this is 1 by 4 plus 3 into the probability that 1 by 2. So, then this is nothing but, if you do this is 2, this is nothing but 4, 1 plus 2 plus 6. So, this is 9 by 4, 9 by 4. Now, this is actually for it is just notation actually mu 1 dash nothing but. Now, if you want to find the variance, so for variance formula it is nothing but sigma square x, this is expected values of x minus mu x whole square. So, then you have to find summation of xk minus mu 1. So, mu x is just mu 1 dash, the 9 by 4 is whole square, you have to make this summation of xk minus mu 1 dash whole square into px of xk, you have to do it. So, then this subtraction you have to do and you have to square it. So, then you will find that then you have to multiply, then you have to find the value. So, it can be done, you can do it. So, this value you can find out what is the value, but we will use the other formula. What we will do? We will find the second order raw moments. So, it is easy to find. Second order raw moment is nothing but mu 2 dash. So, mu 2 dash is nothing but expected values of x square. So, expected values of x square, what is this value? X square px of xk. So, this is the formulas over k, what are the values, possible values it is taking. So, then this is nothing but summation of x square into x. So, this is nothing but 1 square into px of 1 plus 2 square into px of 2 plus into px of 2 plus 3 square into px of 3. So, this is what is 1 square 1 into px of 1 is 1 by 4 plus 2 square is 4 into 1 by 4 plus 9 into px3 is 1 by 2. So, I am finding the probability here. So, then what we will find? So, then this is nothing but this is 4, this is 4, this is 1 plus 4 plus, if I have done any mistake please check it and then you correctly done, you can correctly do it. So, because it is just you have to understand how we are doing. So, here basically it will be little more complicated, that is why you are using second formula. So, then this is nothing but 18. So, this is 23 by 4. So, then variance of x will be sigma square x, this is nothing but variance of x will be, we will use this formula mu 2 dash minus mu 1 dash whole square. So, this is nothing but mu 2 dash minus mu 1 dash whole square. So, then mu 2 dash is nothing but 23 by 4 and then mu 1 dash is mu 1 dash whole square, mu 1 dash we just found it, mu 1 dash is 9 by 4. So, this is 9 by 4 whole square. whole square. So, this become nothing but 23 by 4 but minus 81 by 16. So, then just we have to simplify these things. This will be 16 to 92, I think, yeah, 92 minus 81. So, this is nothing but 11 by 16. So, this variance we can easily found, but if you can try here whether you are getting same value, but it will be little complicated, but you can check it that whether you are getting same value, because we just simply, this is the actual definition and this then we have simplified this formula. Okay. Now, let us before going to the another example, we will go discuss in the continuous random variable cases. So, here we will let us discuss another discrete random variable example we have already discussed. So, you can remember. So, this is for infinite case how we will do it, because we will do more examples. So, this is continuous case, discrete case here. So, you can remember that this is this example. Px of n is nothing but 6 by pi square n square, n equal to 1 to dot dot 0 otherwise. So, if you do find this, what is the mean and variance, let us consider this example. Let x be a discrete random variable, let x be a discrete random variable with the probability mass function given by Px x is equal to, so we took it is n because for a natural number we usually denote like this, n is 1 by n square, or n is equal to 1 to like not 1 by n square. Let us see that there is some constant some multiplication is there. So, I think it is pi square by 6, yeah. So, this is 6 by pi square n square, this is 6 by pi square n square, this is 6 by pi square n square, n equal to 1 to it is 0 otherwise. Now, what will be the mean and variance? Suppose let us find out the mean. So, mu 1 dash is nothing but expected values of x here. This is nothing but summation of xk px of xk. It is infinite taking it is. So, that is why summation of n is equal to 1 to infinity, xk is nothing but n, and px of xk is nothing but px of n. So, this is 6 by pi square n square. So, then you can see that. So, now if you simplify this, this is 6 by pi square constant, then this is n is equal to 1 to infinity 1 by n. So, this series is a, so whether we can find the mean, because if you have to find the mean, then it has to be convergent, but you know that it is a divergent series. This series it is not convergent, this is nothing but this series is divergent. This is divergent. So, it does not exist. So, mean, so whenever mean does not exist, actually higher order moments again it will not exist, because you will multiply mode n square n cube like that, mu 2 dash is will be n square. So, then it will be it will not be convergent. So, that is why it will be divergent. So, mean does not exist, mean of mean mu 1 dash does not exist. Hence, sigma square also the variance also, and variance the variance of x does not exist. So, this is the one example that you can see that for discrete random variable does not exist. So, for discrete random variable mean does not exist, and as well as variance does not exist. So, now let us discuss. So, here you can see one example that mean and variance does not exist of a discrete random variable. So, now we will discuss finding the mean and variance of a continuous random variable. So, continuous random variable we have discussed some of the example, we will take one example. So, let us consider one example. So, it is discrete. So, uniform distribution already we have discussed uniform distribution, mean we have discussed. So, variance also you can find. So, let us do another example. Let us for this case we may have discussed it. So, uniform distribution we did not discuss. Let us consider this function. So, let f(x) is the continuous random variable having the probability density function given by this. So, what will be the mean and variance of this random variable? So, let x be a continuous random variable with the probability density function given by f of x(x), this is equal to 1 by 4 whenever x is greater than -2 less than 2, this is equal to 0 otherwise. So, how to find the mean of this random variable? Because it is a continuous random variable, expected values of x mu1 dash, it will be defined by integration -infinity to plus infinity x f(x)(x) dx. Now, this density function is non-zero only when this is -2 to +2, otherwise it is 0. So, this will be -2 to +2, other interval it will be 0. So, that is why we are not writing again. So, then x into this is density function will be 1 by 4 dx plus 0 and plus 0. So, then this is nothing but 1 by 4 into integration of x square by 2 and you have to do we have to find the limit here, write down -2 to +2. So, this is how it will be. So, this 1 by 4 into this is 2 square minus 2 square 0. So, into 0 1 by 4 into 2 into 0. So, this is equal to 0. So, here mean will be 0. So, now how to find the variance? So, here it is because the variance is nothing but sigma square is nothing but x minus mu1 dash whole square, because mu1 dash coming out 0, it is nothing but expression of x square only. So, that is why we have to find the second order moment only. So, this is nothing but mu2 dash. So, if we can find the mu2 dash, then we can find the variance. So, what is the mu2 dash? So, mu2 dash expression of x square is nothing but integration minus infinity to plus infinity, expression of x square is x square by definition x square f(x)(x) dx. So, now it is non-zero when it is -2 to +2, that is why we will write -2 to +2 x square into density function is 1 by 4 dx. So, this is nothing but 1 by 4 into integration of x square is x cube by 3, this is x cube by 3 minus 2 to plus 2. So, then if you put the limit, I am just writing here, this is equal to, so from here this is equal to -2. So, this is 1 by 4 into 3 1 by 12, and then it is 2 cube, then plus again -2 of whole cube, it will be minus and minus again plus. So, 2 into 2 cube it will be. So, then 2 cube 2 into 2 cube 2 to the power 4. So, that is why it is 16 by 4 into 3. I think if I have done any mistake, you please check it and then make the correction. Any calculation mistake, 2 cube into it will be 16 to the power 4 by. So, then it will be 4. So, this will be nothing but 4 by 3. So, this variance will be nothing but 4 by 3. So, variance of this random variable will be 4 by 3. Now, I hope you have understood how to find mean and variance for the discrete random variable and continuous random variable, and we also gave the one example of a discrete random variable where mean and variance does not exist also. Let us consider this continuous random variable, this another density function we discussed here. So, you can see here one example here given, this is the density function. Later we discussed one density function here. Okay, no, this is mean we found. I think this is, yeah, this is the density function we discussed. So, x is a continuous random variable with c by x square. So, c we found 1. So, this density function is nothing but 1 by x square. So, this density function is 1 by x square whenever x between 1 and infinity. Let us find the mean and variance of this probability density function, continuous random variable. So, let x be a continuous random variable, let x be a continuous random variable having the probability density function given by f of x is equal to 1 by x square whenever x is greater than 1 less than infinity, 0 otherwise. 1 by x square whenever x is greater than 1 less than infinity, 0 otherwise. And then this is the density function we have found. Also we found a probability between 2 and 3 also. Then what will be the mean of the random variable? So, mu 1 dash, this is nothing but expected values of x, which is by definition this is nothing but minus infinity to plus infinity x f x x dx. So, now because it is non-zero 1 to infinity only, so this is nothing but 1 to infinity x, and then density function is 1 by x square dx. So, this is nothing but 1 to infinity 1 by x dx. Now, integration by 1 by x is nothing but log x. So, then if you do 1 to infinity, x goes to infinity, this is actually divergent, this is not convergent. So, this is diverges. So, this is in this case also you can see that mean does not exist finitely. So, it is actually diverges. So, mean, so as mean does not exist, higher order moments also will not exist here. So, that is why this is continuous random variable. This is example of a continuous random variable where mean and variance. So, the mean and variance of this random variable are not finitely, it is not convergent. So, it not exist. Okay. So, what we can write? So, mean and variance of this random variable do not exist finitely. So, this is what we discussed in the moment. So, next I hope it is clear now how to find the first order moment, second order moment, mean and variances for the discrete random variable and the continuous random variables. So, we have discussed some of the numerical examples also. Now, next we will discuss some of the special distribution functions what we usually use whenever we model or data analysis for the most of the data. When we find in the nature, we sometimes we discuss, we find these distribution are very useful. So, Bernoulli distribution, binomial distribution, Poisson distribution, these are the discrete distributions. Some of the continuous distribution like exponential distributions, gamma distribution, normal distributions, we will explicitly will discuss how these distributions looks like, what will be the mean and variance, their distribution function, their probability mass function in case of discrete random variable, their probability density function in case of continuous random variable, we will learn that. Now, we will discuss some of the special distributions which are very much important most of the times in the future in statistical inference or in the data science. You will see that these distributions are frequently we are using. So, we need to learn these distributions very well. So, in details their mean, variances and some of the important properties we will learn here. So, one of the distribution, it is known as Bernoulli distributions. So, from the beginning you have seen that we discussed one of the special example, tossing a coin. So, tossing a coin means it is either head or either tail or tail. So, in that case we most of the times we assume that it is an unbiased coin. So, probability of head is half. So, it may not be half always. We will assume that in general probability of head may be some p belongs to 0 to 1, anything. So, in nature also this kind of random phenomena we find in the nature. So, whenever we are giving medicine to a patient, the response may be categorized into two, one is success, one is another is failure. So, in that case also we can model the data using this Bernoulli distribution. So, here you can see that. So, tossing a coin once, sample space is head and tail, and random variable x S2R may be defined as x of head is equal to 1 and x of tail is equal to 0. So, probability mass function is defined by this. So, how it is related, x of head is equal to 1 and x of tail equal to 0. So, we will discuss, and this is the distribution function. So, now so here we are represented this random phenomena. So, this is the head and this is tail. So, now we are this is a measurable function. So, this is 0, this is 1, this is minus 1, this is 2, minus 2. So, head mapping to 1, x of head is equal to 1 and x of tail is equal to 0, x of tail is equal to 0. So, then we just see what is the probability that x is equal to 1. So, we assume that this is a p, it may not be half always. So, this is in general this is p. So, p is a parameter here, this is inside 0 and 1. So, probability, and probability that it can be tail. So, x is equal to 1 means head occurred, x is equal to 0 means tail occurred. So, it is 1 minus p. So, this probability mass function, so this is probability mass function we general we write the probability mass function of this random variable. So, the probability mass function so sometime we denote just PMF of x can be represented as Px of x. This is equal to p to the power of x 1 minus p to the power of 1 minus x. Whenever x is 0 and 1, this is equal to 0 otherwise. So, how it is related? See that p of x is Px of 1. What is that? Probability that x is equal to 1. This is the probability mass function. Now, Px of x is equal to 1. So, Px of 1, if you put 1 here, so there is p to the power of 1, 1 minus p to the power 1 minus 1, 0. So, this is nothing but p. So, that is the probability of x equal to 1 is equal to p. Now, probability of what is probability of x is equal to 0? Probability of x is equal to 0 is nothing but this Px of 0, probability mass function. So, if you put x is equal to 0 here, so this is nothing but p to the power 0 1, 1 minus p to the power of 1 minus 0, this is nothing but 1 minus p. So, then for any other value there is no non-zero. So, it is this range of x is only 0 and 1. So, now if you draw the probability mass function, so this is very simple. So, it may be useful when we will discuss so more other random variable. So, this is probability mass function Px of x, at 0 it is 1 minus p, at 1 this is p. So, p may be greater than 1 minus p or less than 1 minus p, just here we assume this is p is greater than 1 minus p. So, now what will be the cumulative distribution function? How we will find the cumulative distribution function? The cumulative distribution function distribution function, so CDF of x is how is given by f of x, this is nothing but probability that x less than equal to x. So, how we will find that? So, see that it is taking probability mass function taking 0 and 1 only. So, up to 0. So, if you put x is which is, so whenever x is less than 0 greater than minus infinity, because it is the minimum value at 0 this random variable it is taking. So, this cumulative distribution function up to px of any value, if you put px of minus 1, px of fx of minus 1 or fx of minus 2, what any value if you take, then this value will be 0. Now, whenever x is greater than equal to 0, so then this is nothing but px 0. So, px 0 is nothing but 1 minus p, and it is up to 1. So, that we have discussed whenever we discussed how you can find the probability distribution function from the probability mass function. So, it is the minimum value whenever x is less than the minimum value, then the cumulative distribution function it will be equal to 0. Whenever it is between 0 and 1, so this is next, then it is px 0, and then x whenever it is greater than 1 it is the maximum value. So, this is px 0 plus px 1. So, that is why this is 1 minus p plus p, this will be 1. So, this is less than infinity because it is only 2 value. So, this is the cumulative distribution function. So, if you want to graphically represent this cumulative distribution function, so like this. So, this is 0, this is 1. Now, fxx, suppose if you want to represent it by graphically. So, then this cumulative distribution function will be 0 up to this, then at 0. So, at 0 it is nothing but minus 1 minus p. So, this is the value. So, this is suppose this is 1 minus p, this is 1 minus p. So, this is continue up to 1. So, then it will be at 1, this will be 1 minus p. So, this is equal to this is nothing but p. So, this distance nothing but p. So, this is 1. So, if you like this is 1. So, 1 plus, so this distance is p. So, that total distance will be 1. So, p plus 1 minus p is equal to 1. So, this is the, it is a step function because it is a discrete random variable. So, it will be a step function. This is the cumulative distribution function. Now, we want to find some more, suppose we want rth order moment and also we want to find the mean and variances. So, what will be the rth order moment in general if you want to find. So, then suppose first we find the first order moment like mu 1. So, mu 1 will be mu 1 dash, this is nothing but expected values of x. So, this is nothing but by definition this is summation of xk px of xk. So, it is taking only two value 0 and 1. So, this is nothing but 0 into px of 0 and plus 1 into px of 1. So, then this is nothing but 0 plus 1 into px of 1 is, what is px of 1? It is nothing but probability that x is equal to 1. So, x equal to 1, this is the probability mass function, px of 1 is nothing but p. So, that is why this is nothing but p. Okay. Now, what will be the second order raw moments? So, in general you can, here it is easy to find the rth order raw moment. So, for r is equal to any value. So, then mu r dash, this is nothing but expected values of x to the power r. So, what will be the value? This will be nothing but summation of, by definition, xk to the power r px of xk. So, then this is nothing but, so it is, what are the values it is taking? It is only 0 and 1. This is 0 to the power r into px of 0 plus 0 to the power another value it is taking 1. So, this is 1 to the power r into px of 1. So, then what is the, this is nothing but 0 plus this is will be, this is nothing but 1 into px of, this is nothing but 1, again it is 1. So, this is px of 1 is p, just now we discussed. So, this is nothing but is equal to p. So, for any r 1 to n. So, not only that for r is equal to 1, for any r this value is p. So, hence whenever r is equal to 2 also, so mu 2 dash this is nothing but is equal to p. So, why you are finding this? It is important because we know, suppose we want to find the variance of x of this random variable, variance of x, this is nothing but, so basically this is expected values of, so x minus mu 1 dash whole square, but we know the simplified formula, it is nothing but mu 2 dash minus mu 1 dash whole square. So, mu 2 dash is nothing but p, this is nothing but p square, which is, so hence this is equal to p into 1 minus p. So, this is the variance of this random variable. So, here we just discussed the Bernoulli random variable. It is very simple for finding the mean and variances also, not only that, rth order of moment also you can compute. So, this is one of the important distribution we discussed here. Their probability mass function, how it looks like, and what is the probability distribution function also, cumulative distribution function also we have discussed.